Okay, hello class. Good afternoon or good day to you, to everyone. Okay, no? So let us discuss first, okay, no? Laplace transformation. Okay, no? This way, okay? As it is defined, no, that the Laplace transformation, okay, no? By the given definition, that it is a transformation from, complicated differential, integral, and transcendental functions into, uh, a algebraic function in another domain. So this is very, very important when we go to control systems. Okay, because in control systems, okay, system modeling involves having differential and integral equations which are difficult to solve. To make the manipulation of equations easier, Laplace transform is used to convert these complex equations into algebraic functions in another domain. Okay, so let us go first to another. Okay. So what is okay? What is Laplace transformation about? So when we go to solving problems. Okay. So by definition, okay, let's have this first. Okay. So that the function. So let us have the definition. That the transformation in the S domain is equivalent to e to the integral of e to the negative st, function of t dt, okay, to be evaluated from 0 to infinity. Okay, no? So let me choose first, okay? So if I have, so let us have some examples. Okay, so number 1. So what is if the function t is equivalent to 1, okay, no? So if that is a function of 1, okay, so that the function now in the S domain can be computed as the 0 to infinity e to the negative st function. So we have now 1 as the function of t dt. Okay, now? So in integration, if I have the integral of e to the negative st, e to the u, e to the u du, So to compare that with our equation that we are going to solve, you have to choose, which is your u. So u is equal to negative st, So to derive that, du is equal to negative s dt, So if I have to introduce, here, negative s, So our equation will now become, a different equation without having to introduce here negative 1 over s, So that will be our equation now. Okay. So to introduce here, so since we have introduced, so function, So since I have now the function of s equivalent now to negative 1 over s, 0 to infinity, e to the negative st, negative s dt. So that completes your integration procedure. So if I have now to use this formula, that should be equivalent to e to the u, to be evaluated from 0 to infinity, So you have now 0 to infinity, okay, no? So that will become now negative 1 over s, no? E to the negative st from 0 to infinity, okay, no? So that is negative 1 over s, okay? E to the infinity minus e to the 0, okay? So that will now become, okay? So that will become negative 1 over s e to the infinity is 0 minus 1, okay? So that will become, okay, 1 over s, okay? So that will now be your function of s now in terms of s domain, okay, no? Next, okay, let us solve another, okay? Let's have another example, okay? So another example here. So number 2, what if our function of t in the t domain, so that will become e to the function of e to the at, no? So that will now become your function of s will become now, okay? So again, by definition, we have a problem with my tablet here, okay? Let's make use of another space. Okay, so we have now number 2. Okay, now. So what if our function of t is equivalent to e to the 80? Okay, now. So we have now the function of s equivalent now to, okay, e to the 80, e to the, oops, here, another problem with my tablet. Okay, wasn't good. Okay, so 2 function of t is oops, sorry, should I go with this? So let us have here number 2. Okay, no? So our function of t is equal to e to the 80. Okay, no? So our integral now is, wait, so the function of s is equivalent to 0 to infinity e to the 80 e to the negative st dt. Okay. Okay. So that will now become, okay, so since these have the same base, no, you can have it as, no, in algebra, you can have it as adding the two exponents, okay, no? So that is s minus a t dt, okay, no? So since again, no, we have to use e to the u du is equal to e to the u, okay, no? If we have to choose u equal to negative s minus a t, okay? So our du is equivalent to negative s minus a dt, okay, no? So we have now, okay, no, to represent the du, okay, no? So kulang, we are lacking what? We are lacking the factor of, you know, negative s minus a dt, okay, no? To complete the integral. So if we have introduced, okay, no, the value of e to the value of negative s over a, we have also to introduce here, you know, negative 1 over s minus a. Okay, now? So that will become, okay, now, this is already, the integral now is already complete, okay, no? So you can have 1 over s minus a, no? E to the negative s minus a t from 0 to infinity, okay, no? Okay, now, so this will now become 1 over s minus a, okay, now, if we substitute e to the infinity to the value of t, so that will become e to the infinity, e to the, this one is e to the 0. Okay, na? So this will become, this is now 1 over s minus a, okay, e to the, so this will become 0 minus 1, okay, so that will become 1 over s minus a. Okay, no? So this is the function of x now. Okay, so that is algebraic now in nature. Okay, so that is our second one. Okay, no? So that this is the whole, okay, computation. Okay. Next, okay, no? So can I check this one first? Okay, so where is a broken line. Okay. So shall we have another, okay, another pane? So pane, ulit tayo, okay? Okay. So let us have to share another pane by the so share. Okay. So this time, okay, another example, number 3. Okay, now. Okay. So let us have the brush now. Okay. So what if my function of t is equal to cosine of a t? Okay, no? So again, to get the function of s, that should be equivalent now to, by definition, integral from 0 to infinity of, okay, cosine of a t e to the negative st dt. Okay, no? So that will now become, okay, no? So since this involves two functions, okay, yan, no? We are to make use of what we call the, okay, integration by parts. Okay, no? In the integration by parts, no? Okay, so to review you, okay, no? The integration by parts involving integral of a certain function u with that of multiplied by a function in the derivative function of b, you know? So that is equal down to u, the function u, then the function of b minus the integral of b du, you know? So here we have to determine or, okay, or determine the function u and v. Assign values for u and dv. Okay, no? So if I have here the cosine of 80 to the negative st, okay, no? What if I choose, okay, no, u equal to e to the negative st, okay, no? So since I have to determine du, okay, no? So du now will be equal to negative s e to the negative st dt, okay? Okay, we have to determine also assign the value of dv, you know. If I make use of the dv now, you know, so I can assign dv equivalent to cosine of AT dt. Okay, no? So if I get the integral of this, okay, I can cancel out the integral and the derivative. Okay, no? So making it equivalent to B, equivalent now to, okay? So the integral of cosine is what? Okay, no? Positive sine. The derivative of sine is cosine. So therefore, the integral of cosine is sine. Okay? But still, I lack the value of A here. So I should have to introduce 1 over A there. So this now will become, okay, 1 over A, sine of AT. So therefore, I have now completed, not yet, okay, completed, the needed functions, So I can convert now this integral into this, okay, Then I can now have, so integral of cosine of AT e to the negative st dt will now become equal to u times b. So I have chosen the, okay, u as e to the negative st, then the v, so my v is 1 over a sine of 80, okay, minus the integral of b. So that will be 1 over a sine of 80, okay, Then I have du as, okay, negative, negative s e to the negative st dt, okay, Yan, okay. Sorry for this class, okay. So there is some kind of problem with my tablet, So yeah, okay, so I have already completed now the conversion, okay, from this integral into this integral, okay. So if I have to evaluate the first term, okay, so that should be equal now to, okay, if I substitute e to the infinity, okay, so this will become e to the infinity, 1 over a sine of infinity, okay, minus e to the 0 times, okay, 1 over a sine of 0. Okay. Ayan. Okay. So this will now become, okay, if we evaluate this, okay, this will become 0, regardless of the value of sine of infinity, then it should be 1. But since sine of 0 is equal to 0, so this will become 0. So this whole term will now become 0. Okay, So let us focus now on so since this whole term is equal to 0, shall we focus on this integral? Okay, So this will become minus, okay. Okay. So if I place this one now, 1 over a, so outside of the integral, okay, so we can now have 1 over a, and this one of s, okay, So shall we have it as, So minus s, then 1 over a, so this will become now positive s over a, okay, The integral from, okay, 0 to infinity of sine of 80, e to the negative st dt. Okay. Problem again with the broken, okay, in continuance of my tablet, okay, So taking a look at this, okay, no? Then taking a look at this. This involves no another, okay, no, another requirement for you to have the integration by parts, okay, no? So if we make use of the integration by parts, no? Okay, so that will now become, so to choose which is your u, e to the negative st, okay? And I have now the du as as negative s e to the negative st dt, okay? Then if I choose, okay, my dv, okay, as sine of 80 dt, you know, and if I have to do the integral operation, no, I can cancel, no, the integral, then, you know, so I have now v is equal to, no, sine of 80, no, if I have to introduce, no, a to complete the integral, you know, okay, to complete the integral, okay, I should have also to introduce 1 over a there, you know. Then as to continue, okay, so I have here, no, s over a, okay, no. So to complete by parts, okay, no, the integral by parts, okay, 0 to infinity, e to the negative st, wait, okay, should be, okay, no, u, b, e to the negative st, and my v, okay, v. So this is already completed. I have not yet done the integral here, so v, we're going to, okay, no, integrate. So v is equivalent now to 1 over a negative, no? I should have here a negative value, okay, cosine of a t, okay, no? So then to continue again, okay, so the integration by parts require you to have u dv equivalent to u v minus the integral of v du, yeah? So, let's continue this. Okay, so taking now the integral of cosine of 80 e to the negative st. So what remains from my equation now is, no, okay, s over a, then I have the u, okay, u is, okay, e to the negative st, okay, tapos may b is, okay, b is negative 1 over a cosine of 80, okay, now minus, okay, the integral of b negative 1 over a, okay, cosine of 80, okay, du. My du is negative, okay, s e to the negative st dt. Okay, so this now becomes this here, and I still adjust this now, our adjustment. Okay, so this will now become already jumps. Okay, still have to make use of this small space. Okay, so if I have here, okay, s, so this is negative s over a squared. Okay, this one. So, okay, e to the negative st, okay, cosine of 80 from 0 to infinity. Then this one, negative, 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 you know. So that should be negative, okay, no? So minus, okay, s. This one is s squared, no? So this becomes s squared over a squared, you know, integral of, okay, cosine of 80, okay, e to the negative st dt. Okay, okay. So what can you notice? Okay, what can you notice from this? Okay, this integral and this integral are the same, you know. So if I place this, okay, here, now if I place that here, you know, okay, so can we share another pane? So I have one space here. Okay, so let me copy first. So the problem here is we no longer have a shared, you know. So going back here. So I have here now cosine of 80 e to the negative st. This lacks the dt. Here, problem with my so just let us just okay, no, st dt, okay, is equivalent to negative s over a e to the negative st cosine of 80 from 0 to infinity minus, okay, s squared over a squared, okay, then I have the integral of cosine of 80 e to the negative st dt, you know. Then start the sharing first, then share screen again. Okay. This one came from the last portion of the paint, okay? So can I have to compare this and this one, you know? So if I place this here and on this side of the equation, okay, no? And I can okay, factor out cosine of st. Okay, so that will now be 1 plus s squared over a squared, okay, no? Integral of cosine of 80, okay, e to the negative st dt, okay? So that will now be, okay, equivalent to negative s over a, then introduce now the upper and the lower limit e to the infinity cosine of infinity minus e to the 0, okay, cosine of 0. You know? So this one, because if I make this one, okay, common denominator is a squared plus s squared over a squared, okay, no? So the integral goes back here, no? Okay, with the original equation. It's equivalent now to negative s over a. If I introduce here e to the infinity is 0 minus e to the 0 is 1, cosine of 0 is 1, so that will become 1. Okay, then if I bring this down here, you know, so that will now, what remains is the original equation of cosine of 80 e to the negative st dt. So that this one is positive s over a squared. Okay, so this should be a squared. Okay, this should be a squared. Okay, now, and I have a squared plus s squared over a squared. Okay, now, then I put factor out. Okay, cancel a squared, a squared. So what remains from our equation will be s over s squared plus a squared. Okay, so this is now the conversion of the function of cosine of 80, 0 to infinity. Okay, now, so this one is our final answer. You know, then have it finished. Okay, so shall we stop now? Okay, no? The video, then we will have another example. Okay, now stop sharing, then